All right, friends and neighbors, welcome back to another networking video. So a couple of questions came up on latency when we were talking about things. So I thought I would do a little deeper dive. It's a little dive, not a deep dive, but a little dive into latency and maybe trying to understand a little bit more about, what we see when we actually do tests. Now, maybe another way to think about this particular video is, sometimes you just gotta look. And when you get values back, what do they actually mean? So to get us started, remember that we have sources of latency. First up, we got packet handling, right? Whatever it takes to build a frame, build the IP packet, and then get it ready for transmission on the network, right? Segmentation, reassembly, all of that. And then we've got all of the network devices along the way, and then maybe transmission. So I put a question mark after transmission because really that's 2/3 the speed of light if we're talking about copper here. So is that really a source of latency? So propagation or transmission, not usually a major source of latency. Now there's not much we can do on the host. We can think about what else is running on the host. We can think about our connection speeds, stuff like that. And then of course we have the network. And as you move up in the stack, right, if we start talking about hubs or access points maybe, they're really, really low on the network stack. They don't have very much in the way of brains, although access points do. And so they're not doing a whole lot, and so don't add a lot of latency. But we do have collisions. Switches have to process the source address table. They have to process the destination address, and then they have to do the CRC or the error checking, and so they add some latency. And then we've got routers, which have to process up to layer 3, and so they add latency too, because especially when we talk about busy routers or large routers that are at the core of networks, they can have tens of thousands or even hundreds of thousands of routes in the routing table. Now let's talk a little bit about time scale. Now, especially if you're on a Windows box, most of your timescales are going to be in milliseconds. And a lot of times we'll get a report that says, oh, this took 0 milliseconds. Well, on its face, that doesn't make any sense. So what does that really mean? So as a reminder, 1 millisecond is 10 to the minus 3 seconds, or there are 1,000 milliseconds in 1 second. So sometimes it would actually be nice to see things in microseconds or 10 to the minus 6th seconds. What this also means is that a microsecond is 1,000 times faster than a millisecond. So there are 1,000 microseconds in a millisecond. So think about this when you're talking about processor clocks or network throughput. Anytime something is measured in microseconds, or you can get a boost in clock speed, or you can say, well, I'm doing megabits versus gigabits, right? It's a huge difference. So at the bottom of the slide here, I've got what it means to actually get something below a millisecond. So this is on a Linux host, and Linux hosts usually have a little bit better reporting than Windows, at least in terms of ping. So the thing that I've highlighted is that the time delay in this particular ping is 0.027 milliseconds or 27 microseconds. So it is a fraction of a millisecond. So you get much more detail on what our actual time is. So this is the output from a Linux box. Well, okay, let's add some switches and see what happens here. Now, I was in the lab when I was doing this. This is a packet tracer topology, but that was just for the drawing. I did this actually on the lab multi-layer switches. Everything was gigabit, including the host connections. And all that I did was set up a bunch of hosts connected to switches, and then we just pinged across switches as we went. So what's going to happen here is that we're just adding more network devices. So there I am all the way on the left-hand side, and I'm at 71. And here's our ping to 72. And there's a couple things that I want to point out here, that the reporting here is, right, for the first couple, it's 1 millisecond. So automatically, we're what, 50 times slower than the Linux ping would indicate. So the minute we add a switch, we added 50 times the latency of just 2 VMs or 2 hosts on a hub pinging each other. So that's fairly significant. Now the overall average was 0 milliseconds. What in the world does that mean? It's good, right? If that's all you have, and if you care about a millisecond scale, then you're okay. But if you want to know something more, this is completely inconclusive, right? It doesn't actually mean anything. It just says, oh, 0 milliseconds. Okay, so let's keep going. We're just going to ping across the topology here. Well, now we're up to 73, right? So now we've gone across 2 switches and maybe, sort of 3 switches as we're getting to that node that's connected to the extra switch. And again, we see that the switches are actually performing fairly well. They're not adding a whole lot, right? But they're all doing the same thing. Source address table, maybe VLANs, although this is not a routed topology, right? So we're not doing that. This is just a straight up layer 2 gig switch topology. And again, we have that weird measurement, less than 1 millisecond. Well, that could mean a lot of things. So again, not really conclusive. And then we get all the way over there, and all that we really see is that we've got more returns coming at 1 millisecond. So more returns at 50 times what the smaller topology was. Well, what happens if we go to layer 3? So again, these were gigabit routers. All the interfaces were gigabit interfaces. And so there I am all the way on the left. And in this particular topology, it's routed. So we've got the 192.168 1.0 net, the 2.0.3, and then the 4 net all the way on the, this side, that side, up there. Is it that side? I don't know. Camera. Anyway, you can see it. And so I'm just pinging across one router now. So we're going to 2.1, and we can see that, we're still at the 1 millisecond range or less than 1 millisecond. Our average, again, is 0 milliseconds. But this is a small topology, and this router at this point has 4 entries in its routing table. That's it. Not a whole lot of parsing that has to be done there, and we're unloaded. Going across the next router in the topology, we see, we're up to 2 milliseconds for our delay, and we can see that a lot of them are coming in there. Now, another thing that happens when you go across routers is the routers have to populate their ARP tables, but this is after that's already been done, so that's not what we're waiting for. It's just straight up layer 3 processing. And our average is now up at 2 milliseconds. And then this particular time I got lucky where we got a couple of 2 milliseconds, and our average is back down somewhere between 1 and 2 milliseconds. And there we have it. So what do we got going on? We know that milliseconds are 1,000 times more than a microsecond. We know that some operating systems are going to report things, maybe at a time scale that's different than other operating systems. That's why sometimes it's interesting or fun to go to the Linux operating system to get some reporting that we want. Now this is just the output of ping, and Linux and Windows do ping differently, but there we have it. So there's some real results. So you can get results that are sub 1 millisecond, right? You can measure into the microseconds. And in the routed topology, if I had turned those into multi-layer switches, which I did in another one, but it didn't really add much to the conversation, it does reduce the latency because you don't have as many devices. But you still got a route. Now, were these numbers really a big deal? Well, no. Unless you're in the financial industry, unless you've got a latency-sensitive application, then they are a huge deal. Because remember that we're talking about a 1,000 times difference when we go from switching to routing. Now, if you're loaded, you have more stuff going on. If a router's got to do network address translation, or it's got access control lists, or if the access points or the switches are really busy, it changes things quite a bit. So this was just, let's look at latency, let's actually look at our numbers and try to understand what's really going on there. Next up, I think we'll take a look at how iPerf actually works. What is going on? And then maybe again, can we really understand what in the world the numbers mean? Hey, hit that like button if I helped out. Subscribe to the channel. And hey, whether those packets are going at 1 millisecond or 1 microsecond, may they always reach their destination.